This video is on solid revolution, volume of solid revolution, and the shell method. And here I have this yellow region right here. It's bounded above by the graph of sine of x plus 1. It's bounded below by the graph of cosine of x. And this is the line x equal to 3 pi over 2. So I'm going to take this yellow region right here and revolve it about the line x equal to 3 pi over 2. And this is what the solid revolution looks like. So I want the volume of the solid revolution. This is the yellow region that I'm going to revolve about the line x equal to 3 pi over 2. So the graph here is f of x equal to sine of x plus 1. And then the graph here is the graph g of x equal to cosine of x. So now I'm going to revolve it about the line x equal to 3 pi over 2. It will get a solid that looks like this. And then I'm going to use the shell method to find the volume of the solid. And notice that the solid does not contain this, it looks almost like a cone up here, and then also a cone down here. So the solid that we want does not contain this cone and does not have this cone. So what I'm going to do first, I'm going to divide it into 10 shells and then divide it into many, many shells. And so here is shell number 1. So number 1 will go from x equal to 0 to x equal to 3 pi over 20. The distance from the x-axis to the axis of revolution here is 3 pi over 2. So I'm dividing it into 10 sub-intervals. So the first sub-interval will be from 0 to 3 pi over 20, meaning multiply this number here by 1/10, and we'll get 3 pi over 20. The midpoint right here is going to be 0.2356. For this shell number 1, the radius will be from the axis of revolution to this midpoint right here. And so it's going to be 3 pi over 2 minus the 0.2356. That will give us 4.4767. The height of the shell is going to be the top graph minus the bottom graph. So it's going to be f of x minus g of x at the midpoint, which is x sub 1 star. And so we do f of 0.2356 minus g of 0.2356. It will give us 0.2611. And then the volume for this shell of a cylindrical shell is 2 pi times the average radius times the height times the thickness. So we have the average radius, and then now the height, and then the thickness. And then multiply everything together, we'll get 3.4603. So the volume of the first shell is 3.4603. In terms of x, this is how we write it. And then this is the average radius, which is the distance from here to here. So right here, this is midpoint number 1, which is x sub 1 star. And then this is 3 pi over 2. And then the height of the shell is f of x sub 1 star minus g of x sub 1 star. And then times the thickness of the shell. And then similarly, this is shell number 2, shell number 3, number 4, number 5, number 6, number 7, number 8, number 10. So I just divided the solid of revolution into 10 shells. And then all together, the volumes of the 10 shells is 99.6486. So we add the volumes of the 10 cylindrical shells together, then we get 99.64. And then summation notation is written like this. I will go from 1 to 10, and then here we have 2 pi, and then here we have the average radius, and then here we have the height of each shell, and then here we have the thickness of each shell. Now, and therefore the volume for the solid of revolution that we want will have be approximately 99.6486. And now let's divide this solid of revolution into, instead of 10 shells, so if we divide it into 20 shells, and then the volume will be 99, of the 20 shells will be 99.44, and then I will go from 1 to 20. And then here's 1,000 shells, then we get 99.3729. So the volumes of if we divide this solid here into 1,000 shells, and then the volume is 99.3729. And now let's divide the solid into 10,000 shells, and then here's the volume. This is going to be 99.3729. And then here's the summation notation. And then if we divide it into 50,000 shells, and so the thickness of each shell is going to be very, very small. And then the volumes of the 50,000 shells will be 99.3729. And then here's the rest of it. If we divide the solid here into 100,000 shells, then the sum of the volumes of the shells will be 99.3729. And then for 500,000 shells, and then the sum of the volumes will be 99.372935. And then here's 1 million shells, then we'll get 99.3729. And then eventually, to get the exact volume, what we need to do is divide it into an infinite number of shells, like this. And so here's the infinite sum. And so instead of writing I running from 1 to infinity, we write it as I running from 1 to n, with the limit of n approaching infinity. And then the 2 pi is just a constant, so we can move it and place it in front of the limit here. And for this particular example, the function f of x was sine of x plus 1. So f of x sub I star be sine of x sub I star plus 1. And then g of x was the function cosine of x. So g of x sub I star is just cosine of x sub I star. And when this limit here exists, we defined it as the integral from 0 to 3 pi over 2. And then here we have 3 pi over 2 and then minus x. And then here we get sine of x plus 1 minus cosine of x. And then delta x would just be dx. Now the 0 and the 3 pi over 2, if we look back at the graph, this solid here runs from x equal to 0 to x equal to 3 pi over 2. So from 0 to 3 pi over 2. And so that's where the 0 and the 3 pi over 2, that's where they come from. And then I'm going to expand this integral here. So I'm going to rewrite this as 3 pi over 2 times this expression. and then minus x times the same expression. And then the 2 pi here, and so 2 pi times 3 pi over 2 would be just 3 pi squared. And then over here we just get the same expression right here. Now to integrate this part, this be simple. This is just the integral of sine of x, and then integral of cosine of x. And then when we expand this, we're going to get the term x sine x, and then x cosine of x. The integral for x sine of x, we can use integration by parts, and that's going to be sine x minus x cosine x. And then the expression x cosine of x here, we can also use integration by parts, and that will give us x sine x plus cosine of x. And if we work this out right here, and then it's going to come out as 9 pi to the third over 2 plus 6 pi squared. And then work this out. This is going to come out to be 9 pi to the third over 4 plus 3 pi squared. And so the final answer is going to be 9 pi to the third over 4 plus 3 pi squared. And this is the exact volume of this solid revolution. And that's the end of the video.